Good evening, students. Today we will be beginning our first session on redox reaction. Yeah, in class 10th you might have already learned about redox reaction, isn't it? So redox reaction are those reactions which are simultaneously getting oxidized as well as reduced. Correct? Battery cell is one such example. In batteries, there is simultaneous oxidation reduction process. Ozone depletion. Ozone depletion is another example of simultaneous oxidation reduction. Combustion or burning. Yeah, combustion is always associated with combustion is basically oxidation and something else gets reduced. Okay, always remember this in a balanced reaction. mm, Either there will be electron, excess electron, or the balance reaction without any electron has to be a redox reaction. So that means something should get oxidized, something else will get reduced. Okay. Yeah. So in this chapter, we will be learning oxidation and reduction through various methods. Yeah. And then we will study redox reaction, balancing of reaction. Yeah, this we will be learning in upcoming sessions. Balancing of reaction, there are two ways. One is oxidation number method, one is half reaction method. And then there is redox titration, which is the application of whatever we are learning. And then redox electrodes. Even this is one more application of principles of redox reaction. Okay. So coming to the basic thing, oxidation and reduction. What does this mean? What does oxidation mean? Yeah, we heard previously in 10th, you all might have heard various definitions for oxidation. Yeah, most common one was addition of oxygen is oxidation. Removal of oxygen is reduction. Addition of hydrogen is reduction. Removal of hydrogen is oxidation. Yeah, we will begin with that. Okay, so we will just recollect everything and then I tell you two more ways to find out whether the reaction or whether the given element atom undergoes oxidation or reduction. Okay, so in this case, for example, if I take magnesium, if it reacts with oxygen, then oxygen gets added to this, right? So addition of oxygen. Magnesium oxide form will be example for oxidation. That means Mg gets oxidized. Clear? Similarly, sulfur gets oxidized because O2 gets added to it. Okay? Yes. Methane is another example which on oxidation gives carbon dioxide. Yeah, hydrogen gets removed and oxygen gets added. So it is double oxidation, I can say. Removal of hydrogen is also oxidation and addition of oxygen is also oxidation. So it is doubly oxidation. Huh? Yeah, that's the term, but basically it means that carbon is getting oxidized. H2S. Here hydrogen is attached to sulfur. So if you remove that hydrogen, sulfur gets oxidized. If you are adding any oxygen to sulfur, then it gets oxidized. So here you can see that H2S, two hydrogens are removed as we go to product. So sulfur is oxidized. Yeah. In the presence of oxygen. Yeah. Yes, oxygen we call them as the oxidizing agent. Yeah, whichever undergo reduction or whichever is the component which oxidizes something, that will be oxidizing agent. Adding oxygen is equivalent to removal of hydrogen. In first case, as you can see, there is addition of oxygen, and in the second one, removal of hydrogen. So both will lead to oxidation reaction. Yeah, oxygen hydrogen method. Okay. Yeah. So in terms of hydrogen, if I want to call oxidation, it will be it involves either addition of oxygen, as we saw in the first case, or removal of hydrogen from a compound. So that leads to oxidized product. Whereas in case of reduction, it's reverse, involves addition of hydrogen or removal of oxygen. So this was what you all might have heard previously, right? So it's the same thing. Okay. So magnesium with oxygen gives magnesium oxide is one example. H2S, hydrogen sulfide, getting converted to sulfur is another example. Yeah. Uh, in the same way, here ferric oxide, Fe2O3, getting converted to iron, which means it is losing few oxygen. So it is example for reduction. And in case of H2S, getting converted to sulfur. Yeah, in the same way, for Cl2, H gets added. So these are kind of redox reaction. Yes, it is a redox reaction wherein this gets reduced, or rather I would say Cl2 gets reduced and H2OS gets oxidized. Okay. So yeah, this is one approach of understanding oxidation and reduction reaction. There is another approach which is electronegative, electropositive element method. Okay, so fluorine is more electronegative. Correct? It is electronegative element. So if that get attached to magnesium, if electronegative element get attached to some element, then that we call it as oxidation. Okay. Yeah. Make sure you are understanding that if electronegative element gets attached to some substance, then we call that particular element or compound is getting oxidized. In the same way, if electropositive element, here all three examples, Cl2 is electronegative. So Cl2 gets attached to MgCl2, which is oxidized product. This is getting oxidized. Okay. And sulfur is also comparatively more electronegative compared to magnesium. So magnesium sulfide is formed, which is again the oxidized product. This is undergoing oxidation. Yeah. Yes. So next are few of the examples. Yeah, this is another example wherein you can see that electropositive element, which is K. Yeah, K is electropositive element. It is getting reduced. So that means this particular compound, yeah, electropositive element removing or electronegative element adding, both are oxidation. Yeah, just like addition of oxygen. Oxygen is also electronegative in one sense. That it comes towards the right of periodic table. So that is also electronegative. So addition of oxygen or electronegative element or removal of hydrogen or electropositive element is basically oxidation. Clear? So here I am removing K from reactant to product. That is electropositive element I am removing. Hence, uh, the product formed is oxidized product. Okay. Basically, this is undergoing oxidation. Yes. So this is another way of understanding, and this is more general. Not only oxygen, any electronegative element, if it gets attached, is oxidation. Not only hydrogen, any electropositive element, if it gets attached, then this reduction. Okay. Yes. So here Cl3 is getting removed. One Cl is getting removed. So electronegative element is getting removed. Same like oxygen is getting removed. So then it is reduction. Yeah, it's reduction. Yeah. Yeah. Here Hg. Okay. I can say either Hg is getting added to HgCl2, one more Hg is getting added, which is electropositive compared to Cl. It is electropositive. Since Hg is getting added, electropositive getting added means it is reduction. Clear? Yes. So you all can uh, apply this also in the same way as oxygen and hydrogen. Yeah. Okay. So what is electronegative? Based on that, how I can differentiate oxidation and reduction? Addition of electronegative element, you can remember it as oxygen like, because oxygen is also quite electronegative. Or removal of any other electropositive element. You can remember hydrogen like. Hydrogen like. So sulfur is electronegative. So if it gets added, it's oxidation. Chlorine is electronegative. If it gets added, okay. Here you can see iodine is getting replaced with chlorine. So compared to iodine and chlorine, chlorine will have more affinity. So it will um, replace iodine. That means more electronegative element is getting attached. So that's why again this happens to be oxidation. Okay. Whereas reduction is addition of electropositive element or removal of any other electronegative element. Just like addition of hydrogen. Yeah. In that place we have electropositive element or removal of any other electronegative element like oxygen. So if you are removing oxygen, it is reduction. Same way, if you are removing electronegative element, it is reduction. If you are adding electropositive element like hydrogen, then this reduction. Okay, so as you can see in the first case, this is SnCl2. So HgCl2 plus SnCl2. In this case, this HgCl2, for that I am adding one more Hg. So since I am adding one more electropositive element, this happens to be reduction reaction, and HgCl2 is getting reduced. Okay. Here SiCl4 to Si, 4 Cl are getting removed. That means 4 chlorine, which is electronegative element, is removed. 4 oxygen like elements are removed. So that means it is electro sorry, it is reduction reaction. Yeah. Because oxygen like element is removed. So this is another understanding of oxidation reduction through electronegative electropositive element method. Right. Yes. So if you look at this example, HgCl2 plus SnCl2 gives Hg2Cl2 plus SnCl4. There is something special in this reaction. So if you look from Hg perspective, then you see that this particular compound from HgCl2 to Hg2Cl2, it's getting reduced as I explained before, because electropositive, which is hydrogen like, is getting attached to HgCl2. So that's why it is reduction. It is undergoing reduction. Okay. In the same way, if I observe SnCl2, it is getting converted to SnCl4. Stannous chloride is getting converted to stannic chloride. So then, what is happening in that process? 2 chlorine are getting attached. So since 2 chlorine are getting attached, 2 electronegative, 2 oxygen-like atoms are getting attached, it's oxidation. Yeah. So simultaneous oxidation, yes. Many reaction will happen in that particular manner. And when such type happens, that means simultaneous oxidation and reduction take place, we call such reactions as redox reaction. Yes. Since oxidation and reduction always occur simultaneously, these reactions are called as redox chemical reaction. Okay. So in the given two equations, maybe you can take first equation first. Try to find out which one is undergoing oxidation, which one is undergoing reduction. Always remember, if there is no electron mentioned, plus E minus in reactant side or product side, then it has to be oxidation reduction or redox reaction. Got it? So it has to be redox reaction if electrons are not excess in reactant or product. Okay, I'll give you examples for that even in the like little later. So till then, yeah, you understand this, that this is oxidation reduction or redox reaction, and try to find out which one is undergoing oxidation, which one is undergoing reduction. Quick, quick. You all can reply. Seems like today you came late. Quick, I have to answer this. Yes, what is the answer? Not much difficulty, right? This is the 10th portion. Yes, what is the answer? For first one, hydrogen is getting removed. If I look at sulfur, hydrogen is getting removed. So removal of hydrogen means it is oxidation. So from here to here, this is oxidation. Correct. And if you look at chlorine, for that hydrogen is getting attached. So since hydrogen is getting attached, it is reduction reaction. This is oxidation reaction, and the other one is reduction reaction. Yeah. Yes. So H2S is oxidized because a more electronegative element, chlorine, is added to hydrogen. Yeah, that is one way, or you can also say hydrogen has got removed. Okay. And chlorine is reduced due to addition of hydrogen to it. Okay. Yeah, try second one now. Try second one. Quick. I'm not getting reply. This is very easy. Yes. Why? What happened? Yeah, quickly tell me. Quick. Third one, which is getting oxidized, which one is getting reduced. That much is sufficient. Yes. Yes. Quickly reply. Yeah. Quite easy, right? What is getting reduced? Yeah. One which is losing oxygen is getting reduced, or that reaction is reduction. So I can tell iron gets reduced and aluminium oxygen is getting attached. So aluminium is getting oxidized. Yeah. Aluminium is oxidized because oxygen is added to it. Ferrous, okay. Ferric oxide, ferrous ferric oxide is reduced because oxygen has been removed from it. Yeah. Okay. Next is electrons method. So in electrons method, we will be, yeah, as I had told you that redox reaction means any reaction in which oxidation or reduction take place and there is no imbalance of electron. That means no addition of electron on the reactant side or product side. Then it has to be a redox reaction. Only oxidation is not possible with electrons not being added to oxidation side or reactant side or product side. Okay, that will become more clear when we look into electrons method. Okay, yeah. So for example, if I take this example, 2Na plus Cl2 gives 2NaCl. In this example, 2Na, when it is forming NaCl, obviously sodium is getting oxidized because electronegative element is getting added to it. Yeah. And Cl is getting reduced because the electropositive element is getting added to it. Correct. So that's why here sodium, yeah, that's why this happens to be a redox reaction. Okay. And if I look into more detail to understand what exactly happens in case of oxidation reaction, this is what it happens. Sodium get converted to Na plus, giving out 2 electrons. So I can say that in case of oxidation reaction, electrons are emitted. Okay, this is always true because yeah, they are coming in contact with electronegative element. they lose their electron or they give up their electron. That's why in oxidation reaction, electrons are emitted. And in case of reduction reaction, electrons are absorbed. Okay. So this is another measure of cell telling whether it is oxidation or reduction. Okay. So oxidation reaction, electrons are emitted. Reduction reaction, electrons are absorbed. Okay. Yeah. Half reaction that involves loss of electrons are called redox reaction. Similarly, the half reaction that involves gain of electrons are called reduction reaction. Okay. Wherever there is gain of electron, it is reduction. Wherever there is losing of electron, it is oxidation. Okay. So based on electrons method, I can say oxidation is the loss of electrons by an atom, ion, or molecule. It is also known as de-electronation. Okay. For example, if you take Zn, gives out as Zn2 plus and 2e minus. Okay, so since 2e minus, 2 electrons are emitting out, it happens to be oxidation reaction. Reduction is the gain of electrons by an atom, ion, or molecule. This process is known as electronation. For example, if you take Cu2 plus, it will gain 2 electrons to give Cu. So basically, it is gaining 2 electrons. So it is reduction reaction. Fine. Yes. So sometimes what happens, this is the principle of battery working. So battery, in case of batteries, what happens? This is one typical cell, electrochemical cell. What is the principle of electrochemical cell? The whatever energy it is liberated during cell reaction or any reaction, that is converted to electrical energy. This is what the principle of electrochemical cell is. Okay. So how does the energy liberated during chemical reaction gets converted to electrical energy? That is by movement of electron, isn't it? Obviously, it is by movement of electron. And how does this movement of electron happens? It will happen by this redox reaction only. In one tumbler, if you perform oxidation process, in another tumbler, if you perform reduction process, then obviously when you connect these two, this is a vague idea that I'm giving you. More detailedly, you will be learning in class 12. Okay. So oxidation means electrons are emitted. Reduction means electrons are absorbed. So if this oxidation process is spontaneous, that means you need not to do any effort. Reduction process is spontaneous, let's say. Then what will happen? Automatically electrons will flow like this, and they will come here. So that's what the principle of electrochemical cell is. Okay. So now, which one will undergo oxidation, which one will undergo reduction? It depends upon the competitive electron gaining or losing tendency. So for example, if I take iron and copper, Fe and Cu2 plus, if I take, I'll get very easily Cu and Fe2 plus. Whereas vice versa, it will not happen. If you take a ferrous sulfate solution and if you make it treat with copper, it will not happen spontaneously that you will get Cu2 plus and Fe. FeSO4 and Cu. Yes, Cu2 plus and Fe. You will not get it spontaneously. So this is what competitive electron gaining or losing tendency means. Okay. Compared to iron and copper, copper has more tendency to undergo reduction. As you see, Cu2 plus will take 2 electrons. Since it will consume 2 electrons to give Cu, it is undergoing reduction. Whereas in case of iron, Fe is getting converted to Fe2 plus, giving out 2 electrons. So it is having more tendency to undergo oxidation. Clear? Yes. So electrochemical cell is application of this knowledge that there will be competitive nature between various elements to undergo oxidation reduction. Yeah. Here is another example between zinc and copper. So just erase this. Yeah. So compared to zinc and copper, zinc has tendency to undergo oxidation. Copper has tendency to undergo reduction. So that is why when you put zinc in copper sulfate, that is zinc in copper sulfate means Cu2 plus ion, you will not get Cu and Zn2 plus. Yeah, sorry, you will get Cu and Zn2 plus because it is spontaneous. Whereas if you take Cu and Zn2 plus in zinc sulfate solution, you will not get Cu2 plus and Zn. Why? Because zinc has more tendency to undergo oxidation compared to copper. It has more tendency to undergo oxidation compared to copper. That is the reason the first reaction is possible, second one is not possible. Yeah. Yeah. This same technique is also used for silver plating or gold plating. Even all of this are based on this principle only. If you take silver nitrate solution and if you dip copper in it, okay? If you dip copper, copper is cheaper than silver, right? So if you take a copper some article and put it in silver nitrate solution, Ag has more tendency to undergo reduction than copper. So what happens? Copper gets converted to cupric nitrate and silver will get deposited on the surface of copper. So this is how this electroplating is done. Okay. Even gold plating is done in the similar way. It forms a thin layer of silver around. Why? Because a few copper which are there on the top surface get converted to, it does not convert, it reacts with silver nitrate and dissolves as Cu2 plus and silver gets deposited in place of that. Okay. Yes. So this is metal activity series or electrochemical series. What is it? Potassium is having very high oxidation power. Yes, it has very high oxidation tendency, whereas gold has very high reduction tendency. And this is the order. So if you take zinc and iron combination, zinc will have tendency to undergo oxidation and iron will have tendency to undergo reduction. That is what this electrochemical series gives me information. Whichever is higher in the electrochemical series will undergo oxidation, whichever is lower will undergo reduction. For example, if I take magnesium and zinc, then zinc will undergo reduction and magnesium will undergo oxidation. But so that is this combination. So this gives me the rough idea of which one will undergo oxidation, which one will undergo reduction based on their tendency. Okay. Justify that this reaction is a redox reaction. Can you tell me which one is getting oxidized, which one is getting reduced? To justify that this reaction is a redox reaction. Yeah. Please tell me. Yes, quick. Which is undergoing oxidation, which one is undergoing reduction. You can use electron method for this, huh? So that you will get it. Obvious answer would be that, yeah, something else. But if you look into more detail, you will understand which exactly undergoes oxidation, which exactly undergo reduction. Okay. Yeah, this is very tricky question. I want answer. At least something you can tell me. Okay. Otherwise, I feel that you are not understanding. Yeah. So here, obviously, if I observe it immediately, I can say that hydrogen is getting attached to sodium. So sodium is getting reduced because the addition of hydrogen means reduction. So it is getting reduced. And hydrogen has to get oxidized because something has to get oxidized. Yes. So I can say hydrogen gets oxidized. But if I look into more deeply, if I look into this, then actually what is happening in this sodium hydride, it is getting converted into Na plus and Hi minus. Yes, sodium hydride will be in this form, Na plus and Hi minus. How it attains? Na attains that by losing one electron. So when I see it more carefully, I observe that this is oxidation and not reduction. Clear? If I look into it directly, then my conclusion would be it is getting reduced. But if I observe more carefully, it comes as oxidation, and H is getting converted to H minus. So H2, here 2Na is getting converted to 2Na plus by giving out two events. Just to balance, I am multiplying it with 2, and H2 is getting converted to 2H minus. And how will it get converted? Each hydrogen atom is getting one extra electron, and such two hydrogen atoms are getting converted to 2H minus. So that means they are absorbing two electrons. So this is reduction. Clear? So now I would like to make one point. The most appropriate way to find out which is getting oxidized and which is getting reduced is the electron method. Okay, but since in this particular question, if you would have thought that sodium is hydrogen is getting added to sodium, so sodium is getting reduced, then your answer is wrong. No, sodium is getting oxidized. Why it is getting oxidized? Because it is giving out electron. In other sense, if you look electronegative, electropositive theory, sodium is more electropositive. Okay, so even in that theory, if you observe very carefully, if hydrogen attaches, hydrogen is electronegative to sodium. Right? So electronegative, if it attaches to electropositive, it is reduction. Got it? Only if you stick on to hydrogen means it is reduction, then it will be wrong. If you come to electropositive, electronegative theory, it will be correct. If you come to electron method, super, it will be perfect. Okay. Yes. Yeah, so here you can see Na is oxidation, H2 is reduction. Now there is one more method which is oxidation number method. This is like more simpler form of electron method which we will be looking at it. Okay. What is this oxidation number? It is notional charge. Okay. I'll explain that. It is notional charge obtained on an atom of an element when the chemical bonds are broken, assigning the electrons of a bond to more electronegative element. For example, if I take HCl, then if I try to split that HCl, it will come out as H plus and Cl minus, isn't it? Because Cl is more electronegative. Yeah, so that this charge which is there, plus 1 or minus 1, that itself is the oxidation number. Got it? Yes, it is notional charge obtained on an atom, on hydrogen as well as chlorine, when chemical bond between H and Cl are broken by assigning electron of a bond to more electron. So this bond gets shifted to chlorine, so it goes to Cl minus. Okay, so that's why here oxidation number one will be plus 1, here it will be minus 1. Similarly, if I talk about H2O, HOO. So when say I break one bond, then what will happen? HO minus plus H plus, correct? Because oxygen is more electronegative compared to hydrogen, so oxygen will get negative, hydrogen will get positive. Okay. Further, it can go, and if I take OH minus, even if I try to break this bond, what will happen? H will get again a plus and O will get 2 minus. So notional charge or oxidation number of oxygen would be minus 2. Oxidation number of hydrogen would be 1. In both cases it is 1, so it will be 1. Clear? So this is what is oxidation number. How it helps I'll explain little later, but let us try to understand oxidation number in more depth. Yeah. In case of coordinate bond, you all might have heard coordinate bond because the chemical bonding chapter is already done. It gives +2 value of oxidation number to less electronegative atom and -2 value to more electronegative atom when coordinate bond is directed from less electronegative atom to more electronegative atom. Let's say X is there, Y is there, and there is a coordinate bond between X and Y. So what does this coordinate bond means? It is a bond where just like covalent bond, there will be two electrons which will be equally shared between X and Y, but both the electrons belong to one particular atom only. Correct. So initially, both these electrons belong to X, let's say, and let's say Y is more electronegative than X. Let's say if that is the condition, what will happen? As soon as X gives both of its electron for bonding, Y is more electronegative, so it will try to take both the electron. So that will lead to +2 on this X and -2 on this Y. Okay, that's what they are saying. If coordinate bond is formed in such a way that less electronegative atom is giving both the electron to more electronegative atom to form coordinate bond, then the electronegative atom, which is Y, will get -2, and electropositive element, which is X, will get plus. Okay. If coordinate bond is directed from more electronegative to less electronegative atom, so let's say in this case, in place of X giving both, Y gives, let's say, both to share with X. Then what will happen? Y is more electronegative, isn't it? Y is more powerful. So it will not allow X to take anything. So even if it gives both, it originally belongs to Y only, and Y has the power to take it back. The oxidation number in that case will be 0. Got it? Yes. So then its contribution be 0 for both the atoms. Clear? Yeah. Yes, students, you all can reply if you are understanding or not. Yeah. And try to be interact through chat at least. Huh? Okay. Oxidation number. What will be the oxidation number or notional charge on this phosphorus in case of phosphoric acid, which is H3PO4? Yes. So in this case, if I look into this, if I try to break one after another all the bonds, first when I break this bond, this two electrons which are present are going to go to oxygen because obviously oxygen is more electronegative. So that will get -1 and phosphorus will get +1 from this bond. If I break this bond, this oxygen will get -1, this phosphorus will get +1. If I break this, there are two bonds. That means totally phosphorus has shared two electrons with this oxygen. And oxygen is more electronegative, so it will try to take both of them. Hence, this will get -2, this will get +2. Getting it? So from above, it is getting +1. From left side, it is getting +1. From below, it is getting +2. Whereas from this side, when bond breaks, this both the electron will go here because oxygen is more electronegative, right? So phosphorus again will get +1. Yeah. So oxidation number of oxygen would be, oh sorry, phosphorus would be 5. Yeah. Because the when you break all the bonds of phosphorus, you observe that oxygen will take away 5 electrons, notional charge, to say, has a tendency to take away all the electrons from phosphorus, and that's why the notional charge, the apparent charge on phosphorus could be +5. That's why its oxidation number is +5. Next, Carros acid. Yeah. Try doing this and tell me the answer. What will be the oxidation number of sulfur in this? Just break all the bonds and put charge on the um, respective electronegative atom among the two. Yes, tell me the answer, quick. I'm not hearing from anyone. Yeah. What will be the oxidation number of sulfur in case of ferrous acid? Yeah, tell. Quick. Quite easy. It's not difficult. Just try to split everything and then tell the oxidation number of sulfur. When equal bonds break, for example, here if this bond breaks, then there won't be any charge developed in either of them because equal bond, right? Both are oxygen, so it will be 0 and 0. This is just the side information. Both will be 0 and 0. Only when there is an unequal breakage that apparent charge occurs. Electrons will tend to shift to electronegative side. Okay, Dinesh is saying 6. Good. Yeah, so it is. How it is 6? Here it will be -2. Here it will be +2. Because when bond breaks, sulfur has shared 2 electrons and this oxygen has a tendency to take both the electrons. Here if bond breaks, here -1 will come. So +2 and from left side it is +1. From below again -2, +2. +2 will be from below. And from this side when it breaks, it will be +1. So if you add all together, it comes out to be 6. Okay. Yes. What about this? H2S2O5. H2S2O5. What about this? Here there are two sulfur. You can tell me oxidation number for both of them. Okay. Yes, what will be the oxidation number? For first one, let's say this is 1, S1, and this is S2. Tell me, what will be the oxidation number for S1 and S2? Yes, same way, quick. Here if it breaks, -2 and +2. From below if it breaks, again for S1, or I'll write 1 above. For S1, it is +2 from above, +1 from left side, because when this breaks, it will get +1. Then from below it is +2. So altogether 5. Whereas for second one, if it breaks from here, +1, from above if it breaks, +2. Whereas if this breaks, there won't be any movement of electron. Okay, it will be equally distributed. So that's why I'm ignoring that. Hence, 3. Okay, fine. So S1 is 5, S2 is 3. Try out this CrO5. In this case, what will be the oxidation number of chromium? Yes, very good, Dinesh. It is 5 and 3. Yeah, because sulfur, it won't develop any charge on either of these. What about chromium? Quick. Yeah, this type of questions can come, huh? Like rarely this type of questions will be there directly or indirectly, though it will come only because some or the other way it will be there. So it should not take more than maybe 30 seconds. Quickly, you should be able to tell. For this, what is the answer? What is the answer? Don't get confused with this numbers. Okay, you try your way. Whatever it is, ignore it and try your way. Very good. It's 6 because when this breaks plus 1, such 4 things are there. So 4 into plus 1. Now I'm moving a little fast. And when this breaks, plus 2 minus 2. So it is plus 2, which is 6. 4 into 1 plus 2, which will be 6. Okay. Yes. Here, what will be the oxidation number? You will have to think very carefully for this sulfur, this sulfur, and this sulfur. Yes. Yes. Na2S4O6. What will be the oxidation number of each sulfur? Maybe you can take this as 1, 2, 3, 4. Quickly reply. Yes. What is it? Yeah. Not more than 30 seconds. It should be very quick. For first one, how much it is? For first one, yeah, it's 5. For second one, 0. Third one, 0. For fourth one, it's 5. Got it? Yeah, try it on your own. Here, oxygen is electronegative, sulfur is electropositive. So, electropositive is trying to give to electronegative. So, that will lead to plus 2. Each bond breakage will lead to plus 2 on electropositive and minus 2 on electronegative. Similarly, here also minus 2 on this oxygen, plus 2 on this oxygen. Here, minus 1 plus 1. So, plus 1 plus 2 plus 2, which is 5. Whereas in this case, bond breakage between equal atoms. So there is no development of charge. So hence it will be 0, 0. Whereas in this case, again 5. Clear? Yes. Always remember this. In coordinate bond, if electropositive is giving to electronegative, then oxidation number of electropositive will be plus 2 with respect to that bond and minus 2 for the electronegative element. Okay. Na2S2O3. The structure is like this. Try to find out oxidation number of this sulfur as well as this. Yes, quickly tell me the answer. Yeah, quick. Quick. What is the answer? S star and then S. Same way, just you can think for a while and yes, oxidation number of sulfur would be plus 4. Plus 1 from right, plus 1 from left, plus 2 from below. From above it is 0 because both are equal, right? Whereas in case of this sulfur, it is receiving 2 electrons from below sulfur, but both are equally electronegative. So that's why it will be 0 and 0. Okay. So that's why above sulfur has, okay, yes, 0 and S star will have plus 4. Okay. I hope Dinesh understood his mistake. Yeah. Above sulfur, we won't give minus 2. Why? Because both have equal electronegativity. Okay, only when giver is electropositive, receiver is electronegative, then oxidation number will be +2 for the giver and -2 for the receiver. If giver is electronegative, receiver is electropositive. Okay, giver is electronegative and receiver is electropositive, there won't be any development of charge on bond breakage. Okay. Yeah. So what about this? It's already done. Yeah. Oxidation number of calcium is +2, oxygen is -2, chlorine is +1 in one case and -1 in another case. Here, why it is +1? Compared to oxygen and chlorine, if bond breaks, chlorine will get positive charge. Because oxygen has more electronegativity, it will take away another electron. Clear? Yeah. So I think with this we'll end today. Tomorrow's class will continue further redox reaction and the main part. Yeah, after understanding more about oxidation number, we'll go to main part, which is balancing using oxidation number. Yeah, yes, which is quite important. Huh? Because 10th, whatever you learned using trial method will get more refined in upcoming class. Okay, thank you very much. Yeah, and I was very happy to have good interaction. Okay, all of you can please interact. Thank you.